All right, let's do this. So, uh, destroying NASA using their own formulas when the math doesn't math. That's my. I'm doing voices now. That's my impression of someone being very mad about something they saw on the internet. So Isaac Newton said the force of gravity on the surface of the Earth is 9.8 meters a second squared. Right? Okay. I think that's the same thing. Like I believe I've heard it at like 32 feet, right? Which would be the same thing as 9.8 meters, right? So that's your acceleration, right? That's the force of gravity. Um, the NASA says gravity drops as you leave Earth. Okay, we know that. NASA also says the ISS is 400 kilometers above the Earth. So the force of gravity at that altitude is 8.7 meters a second squared, which is only an 11% drop. So if you weighed 160 pounds on Earth, you'd weigh 143 pounds on the space station, which is, not bad if that's the result maybe of a diet, but like as it's not like floating around in space, not floating around in space levels of gravitylessness, right? And this kind of makes sense. The 11% drop, if you think about the space station, it's in space, but it's not that high up off the Earth, right? I mean, I don't I don't have a model of the Earth in front of me, but I would imagine if you think of the Earth as a ball and you think of the space station up here, the space station is not like further out into space than the center of the Earth is from the surface. You can kind of think of it like that. It's not as big a distance as you think, and so maybe 11% drop makes sense here. So what's going on here, right? Like this seems pretty good. I mean, the math is there, right? It doesn't seem like based on that gravity difference you should be floating around. So let's see what we get if we just put it in like this. We're just going to hop over to AI mode like this, and we'll see if it's thinking. Okay. All right. So the International Space Station and the astronauts inside are in a constant state of free fall as they orbit the Earth, right? So the image presents a common misconception about gravity in space. While it's true the gravitational pull of the Earth is weaker at the altitude, it's not zero, as it said, still about 90% of what it is on the ground. But astronauts on the ISS are floating or appear to float because they're in a continuous state of free fall along with the station itself. So the ISS is constantly falling towards Earth due to gravity, but its high orbital velocity causes it to continually miss the planet. So, when you're in an orbit, you're sort of in a constant free fall, right? And so when you look at this here, she is floating for the same reason, I think, for the same reason that, if you have a person that is, jumps out, parachuting, they're floating. She's in free fall. And so that's what's going on here. And so this is an interesting one in that you see this a lot with misinformation, where someone will give you perfect math, but the math actually addresses the wrong part of the problem, right? The math here, like when you look at it, you're like, that math doesn't make sense. But it's addressing the wrong reason why people float on the ISS, right? And so one of the neat things I do find about AI and AI mode, but any LLM, is they're good about finding what I call the unknown unknowns. And what I mean by that is it's hard when you're looking at something like this, right? Like this. It's hard to know what is the thing I'm missing here, right? Because you can see this thing and you can look here and you can do the math. But to broaden out and say, what is the thing I don't know that would change my impression of this? That's a harder thing to kind of find. That's a harder thing to search onto. But in this case, it explains it. We might do something like, I think that's pretty easy to understand, but This is what we call aspirational. I don't think he'll do this, but what the heck? Feeling exploratory. So can we find an animation that demonstrates this? YouTube video titled, okay. Let's see.
Save money with Snapshot ProView. Instant savings on your commercial auto insurance and
Hop over that.
And that is, what is an orbit? Well, this is what an orbit really is. It would fall to the floor,
So
100 yards before it fell, because the cannon gave it that velocity.
So this is an explanation, not necessarily a...
They are all the time falling
animation
towards the Earth, going...
But we've got in here, maybe...
due to gravitational attraction.
all right.
So where would...
So, I mean, we're not going to sit here and watch YouTube videos together. Sorry. But, we're here. We can watch some YouTube videos. Now that we have the basic framework for thinking about how to conceptualize this floating, really not as a little gravity in space on the space station, but really as being in a constant state of free fall. Now that we have that, we can look at some of these things. We know to find these animations and learn a little more about how that works, how the physics of that works. So pretty easy one today, but we'll call that one in the can. Talk to you later.